Okay. I guess, how we want to start talking about what we're going to do here is graphing polar curves. And, you got R is some f of theta here. R is some function of theta. This is describing all our points, R versus theta. We're going to now start to graph polar curves. And the reason you need to do, or let's say approach this from a polar perspective, is because very often it's very difficult to graph this in terms of rectangular coordinates, x and y. So I'll give you your first example. And my first example, I guess I kind of like starting to graph my polar curves would be really to start with a very special class of curves. How about if we keep it even more simple? We're just going to say 1 plus cosine theta. Okay? So we're going to graph this, and we have to know what this really is. So let me give you an approach here that we can start. Hopefully this is an example in the book. Is this an example? Because I think it's cheesy if you do examples, the book's examples. Sometimes it's unavoidable because the book has some really, really good examples. So I kind of want to double check, and I hope this is not in the book for this kind of question. Okay, no, it's not. But it's similar, but it's not. Okay. So we're going to see what kind of graph this looks like. Now, we're going to have to plot on our polar axis, really, points. So you're going to first start with the concept of plotting points. But we have to determine what those points really are. So we're going to have to find R versus theta, and here's how you approach it. I'm going to say start by graphing here. Consider this your theta axis. Consider this your y-axis. Very often, this is Cartesian. We know how to graph sine or cosine. We know how to graph those curves. But you have not R, but y here. So what you're really going to do is, even though you're graphing in polar, you're going to actually call this axis here, not your y-axis, but your r-axis. So you're going to graph R versus theta, okay? And you might say, what do I have to graph? Well, you're going to graph R is cosine theta plus 1. Okay? So you start with this rectangular system of R versus theta. Your y-axis is the r-axis. The x-axis is the theta axis. Now, you guys should know how to graph this. This is cosine theta plus what? Plus 1. Is that true? So if you said to me, well, I know what cosine theta looks like. I know what that curve is. This is 1. Here's negative 1. Is that right? What does your basic cosine curve really look like? Remember, one cycle, you go from 0 to what? 2 pi. Midway is pi. Pi over 2. And maybe what? 3 pi over 2. And I know it's a little tricky to see, but I'm going to use these lines here to represent the unit 1. And that's starting to graph sine. We have to graph what? Cosine. Doesn't cosine look like this? Okay, so far so good. This is my cosine curve. This is one cycle of cosine. But don't forget, this may be cosine, but we have to shift this up what? 1 unit. Is that true? So every one of these key points, here, 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 and here, all these points are shifted up now how many units? 1. So that would mean that this is now 2, and that the point here that I just emphasized, that would now be shifted up 1 unit. This second point is shifted up 1 unit. Okay, this next point is shifted up 1 unit. This point is shifted up 1 unit. And this point is shifted up 1 unit. So I'm going to go back now and erase those points. And I guess it's easier said than done. Here we go. Those are no longer there. And what I sometimes do is I draw this imaginary axis here. And what I know is I'm going to shift all my points. I guess we got one that was not there. There we go. We got erased it. Now let's actually draw this curve. So let's change colors. Maybe this is going to be here in black. So I'm now up here. Down here, and back up here. This is the graph, really, of cosine theta plus 1. Now let's erase this. It's not there. And see if we need anything else. Looks like we're good. All right, you guys okay with this? This is how you start to graph really in polar, ironically. Okay, we have to look for some points here. We're going to try to plot some points in polar. That's the key. Now, in purple are all the points we want to draw. Bless you. We want to graph everything in purple we want to actually determine. So let's kind of determine those points. What r versus theta? What is this first point here on the r-axis, right? Isn't that radius 2 angle theta 0? Isn't this radius what? 1 angle pi over 2? Isn't this radius what? 0 angle pi? And what is this over here? Radius 1 angle, what's my angle?
3 pi over 2.
Good. And then what's my radius here?
2.
And what's the angle?
2 pi.
So I'm actually looking at all of these points right here. Okay? You guys okay with that? I need r versus theta. This is my starting point. So I know when you say you're going to have to plot points, you say, okay, we're going to plot 2, 0. We're going to plot 1 pi over 2. The next point is going to be 0 pi. And then we're going to plot 1, 3 pi over 2. And then we're going to plot what? 2 comma 2 pi. These are all the points you want to plot here. And let's plot it in order. So far, so good. Everybody okay with that? We're going to try to see what this looks like here for us. All right, let's see. If we really look at this, this is r, this is theta here. What's that first point? Radius 2, angle 0. Where would that be? Well, it's on the polar axis, right? Here's my polar axis. That angle is 0. What's the radius of 2? 1, 2. Would you guys say it's right here? That's this first point right here, 2, 0. Anybody have any questions on that? Let's put it in red so you guys can see. Maybe not. Maybe red doesn't do it justice. So undo, undo. Let's color it black maybe. So we're here. That's our first point. So now you guys understand why I had to spend all that time here on this way. And maybe we might have to eventually make this a little what? Bigger. Ah, we do. Might have to make that a little bigger. Anyway. We'll see what happens. Okay. What's the next point?
1.
1. What else? Pi over 2? Okay, where is that going to be? 1 pi over 2.
At 90 degrees.
90 degrees. And the radius now here is what? 1. Is that true? So it looks like we're going to be here. Now I want to point out a detail for you guys here. What happened, and I'll paint this in red, between the first plotted point and the second plotted point? What happened, focus on this region right here. As my angle went from 0 to pi over 2, right? 0 to pi over 2, my radius went from 2 to 1. So in quadrant 1, my radius is going to have to go from this value here, where 2 is, to this value here, where 1 is. I'm going to have to draw my curve going this way. So far, so good? I'm going to call this here, it's small. Can you guys see that? This corresponds to, let's say, portion 1 of my curve. Okay? That's portion 1. And I went from radius of 2 to a radius of 1. Now, in the second quadrant, if you said to me, we're going to plot this point down here, 0 pi. Where is 0 pi? Do anybody want to tell me where 0 pi would be? Well, 0 pi as a point, it's, what is it? Yes, it's the origin, it's the pole. So if I label this portion here the graph, now going from, I'm going to erase this here. I'm going to say focus on this portion here. Okay, erase this here. This is portion 2. So from 90 degrees, pi over 2, down here, to 180, really quadrant 2. What happened with my radius? I went from 1 to what? To 0. So in this quadrant, I have to go from a radius of 1 now, okay, to a radius of what? 0. And it kind of looks like this. I know it's not so pretty, but let's do it like that. Does everybody agree with that going on? It just curves down because you go to the pole. You know, at that point, it's 0 pi. You're going where? To the pole. Okay, you with me on this? So, and this is going to be what happens really in what we describe as, I don't know, portion 2 of this graph here. And we now have to focus on portion 3. So I'm going to get rid of this so we can focus on portion 3. Now you might say, what is portion 3? It's right here. Can't write it there. That's too tiny. We'll say 3 right here. Okay? We're going to go from the 0 radius to a radius of 1. Is that right? So in quadrant 3, from pi to 3 pi over 2, quadrant 3, right in here. Quadrant 3. What does my radius go to? 0 to what value? 1. So I'm going from the pole to a radius of 1. What is that? What is that angle? 3 pi over 2. 270. And then I have to go radius of 1 right here. So if I put this in purple again, here's the point. What I'm saying here is you're going from a 0 radius to a radius of 1 now. And let me back up. This is kind of what it looks like. And I'm kind of exaggerating it, but oh, I didn't know we could do this. Oh, wow. Oh, what do you guys think? I didn't know we can make that bigger.
So it's like a
Beautiful. Beautiful. Let's clean this up. What do you guys think? Here's that radius. Oh, here's a radius 1. Oh, here's my radius 1. Okay, here's the point 1. 3 pi over 2. Let's get rid of this. Wow. So I'm going to go back from a radius of 0 to a radius of what? 1. And this is how we describe that third part of the curve. Portion 3 of this curve. We now have to look at portion what? portion 4. Ooh, look at that. Huh, learned something.
How do you know how the curve behaves or how it turns?
Okay, let's go through here. Well, these are continuous. In other words, this cosine curve is a continuous curve, so it's smooth. So what's happening now, like if I look at the last portion here, I'm going to go from this point here to this point over here, meaning the point 1, 3 pi over 2, to the point 2, 2 pi. Okay? Now, where is this point here? Because if you remember, we said we're going to go plot every one of these points. We're now at this last point here. So you have to know where 2 pi is. Could you tell me where 2 pi is? We're good. Right where we what? Started. Right in here. So this is right where we started because this angle here of 0 is also what? 2 pi. And the radius here is we still have that radius value. Right here is 2. So I'm going from this point here to this point here. And the portion of the curve we're talking about now is actually 4. So your question is going to be, hey, Mr. Judge, how is it that we went, when we go from here to here, portion 4, how do we know it's this nice, smooth, continuous curve? Well, because what I just highlighted was nice, smooth, and continuous. From the angle here, 3 pi over 2 to 2 pi, we're going from a radius of 1 right here to a radius of what? 2. So draw a nice smooth curve going from a radius of 1, here it is, here's 1, to now a radius of what? 2. So this is really what you're looking at. Now, it's not that pretty. You'd never guess my parents are artists. Both my parents. But what I just drew a picture for you guys here is a very, very special shape. Anybody know what this shape really looks like? Let me get rid of this other portion 1, portion 2, portion 3, portion 4. What does this actually look like? Does anybody know? If you had to name it, what would you name it?
A heart shape.
It's a heart shape.
But the book calls it a cardioid.
It's a cardioid. Yeah, that's right. The book calls it a cardioid. So you have really looked at a very famous curve, or a class of curves you're going to see, called cardioids. You've actually graphed a cardioid. Now, a cardioid here is, you're right, it's a what? It's a heart. And I guess that's where you get the word cardiac from, and heart, cardiac arrest, cardioid. You guys know what I'm saying? Valentine's Day, hopefully you have a heart, okay? But yeah, in mathematics, we can actually describe cardioids. Okay, we could actually graph hearts. You just graphed a heart in mathematics. Now, you couldn't do that normally in Cartesian coordinates very easily. Does anybody know why you can't really do that very easily, this cardioid here? Right, this radius here, let's give it a detail. It's my radius 0 over here. So you can see how my radius values change for every angle. You got this heart, this cardioid. What was my original question to you guys? You guys remember? What was that question? Can't really do this very easily. Here's my equation. So I'm going to say to you, by the way, because I'll give you a very comprehensive view on this. R is 1 plus cosine theta. Okay? That this cardioid that we just graphed here, make it prettier or make it bigger, that heart we just graphed. We can describe this in rectangular coordinates. What did we do yesterday? Remember what we did yesterday? We multiplied both sides by r here. Remember this work you guys did? You guys do that homework? R squared now will be r plus r cosine theta. And what did you replace this r squared with yesterday? And the r cosine theta with yesterday? Yeah, this is going to be x squared plus y squared. Oops, let's change this. And what's r cosine theta? Translate your x. X squared plus y squared minus x is what? Is r. What should we do now with this? Do you guys know? What do? Square this. Don't complete the square. You'll get x squared plus y squared minus this x to the second power is r squared. What do you replace r squared with? Right here. Again, what is this? X squared plus y squared. So if you ever see the equation x squared plus y squared equals x squared plus y squared minus x, let me write it nicer. Raised to the second power. If somebody ever says to you to please graph this equation, and you said, wait a minute, that looks pretty what? That doesn't look right. Is that a parabola? Is that an ellipse? Is that a hyperbola? You're going to tell them, no, that's not a parabola, ellipse, hyperbola. That's not even linear. You're going to go back and say to them that this actually is this equation right here. R equals 1 plus cosine theta. And the technique that you use to graph this is all the detail that we looked at here. Now erase some of this. All the detail you guys looked at here. Erase that. Don't like that. Bugs me. Bugs me. All this detail of looking at how to graph R here is 1 plus what? Cosine theta. You took all that information and you applied it to your polar coordinates, and you created this cardioid. So the method for graphing cardioids is what you guys see here. And that's what we're studying, and there's a lot of different graphs you can see. There's so many graphs that you can see here. It's unbelievable. When I introduce this to a trig class, I start with cardioids, and I go to these others, roses and lemniscates, other kind of graphs, and you start to get a good head start on that. So this is really what's expected in other classes at times, that you may have to graph a cardioid in your life. And it starts by plotting these special points and looking at those special regions of the curve. This curve 1 plus cosine theta for R is equivalent to, in Cartesian coordinates, what you guys see here. What do you guys think? Is that okay? Believe it or not, let's go to another example. I'll give you another cardioid. And by the way, I'll give you the general form of cardioids. The family of cardioids. If you look at your book, your book will say, what's your family of cardioids? Do you guys know? It's really this. R equals maybe A, okay, 1 plus or minus cosine theta, or R is going to be a 1 plus or minus sine theta. This gives you your what? Cardioids. So I'll give you another example. How do we say R here is 2 plus 2 sine theta? Or did we do, which was the first one? Is that plus or minus? Oh, plus. Well, we could do plus again, or we could do minus. It doesn't matter. Should we try minus? Or should we try plus?
Try minus. Never say minus.
Never seen minus. You want to try minus? You guys are feeling, just stick with your what? Stick with the ideas you know and love. Don't invent anything. We're going to graph this. It's going to be a cardioid. Do you guys know why it's a cardioid? It satisfies that equation here. A here is 2. So how do we start to graph cardioids? Do you guys remember? You need to really graph R is 2 sine theta plus 2. Do you happen to know what's happening with this graph? Say yes. You're graphing, first of all, 2 sine theta, and then you're going to shift this graph up how much? 2 units. Those are some details you're going to have to know. So we have to graph that. And once we graph that, we'll get all the information we need to move on. So remember, you're going to create this here. Maybe down here. Theta r. You okay with that? So does anybody know why did I do things this way? Well, if I have to graph 2 sine theta, what's the graph of 2 sine theta look like? My amplitude is what? 2. Is that right? So this is 2 pi. Halfway is pi. A pi over 2. 3 pi over 2. And what's my amplitude again? 2. So this is 2. And this is minus 2. So I'm going to do it this way. If you guys remember, what do? We draw the sine curve. And I guess it's okay. It's an okay sine curve. Let's actually, if we write it upside down the way I did. Okay. There's a sine curve with the amplitude 2, but what are we supposed to do with this sine curve? Shift it up 2. Why? Because we're adding 2 to the 2 sine theta. So if I shift this up 2, what I want to say is, you see this theta axis? It also goes up what? 2. And in some ways, if we look at the points here now, this point at the origin is up 2 now. At pi over 2, I'm at 2. I have to go up what? 2. And then at pi, I go up what? 2. And then here, 3 pi over 2, I go up what? 2. And at 2 pi, I go up what? 2. So all these other points got shifted. Is that true? So if I sketch this curve now, I go here, 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 and here. So I can get rid of my, whatever you want to call this, ghost curve, I don't know. What do you want to call it? You can get rid of our framework here. And so now we just have to read the graph here. So I want to remind you guys a couple of things. What are the coordinates here? I'll put it in purple. This is 0. My angle, well, let's go back. Let's be careful here. They want it to be an r versus theta. So what do I say about this first point right here? Radius is 2, angle is 0. Is that right? My radius is 2 here, angle is 0. What's my radius here?
4.
What's the angle?
Pi over 2.
There you go. What's my radius here?
2.
What's the angle? Pi. What's my radius here? What's the radius?
0.
What's the angle?
3 pi over 2.
Good. What's my excuse me, what's my radius now?
2. That will be the radius.
What's the angle?
And 2 pi.
So my radius is going to vary from actually 0 to 4. Everybody okay with this so far? So far, so good? I'm going to label this region here. 1, 2, 3, 4. Let's go and plot this stuff. Okay, now I need to bring in what? Here's my polar axis. What kind of shape is this going to be? It's a cardioid. Let's take a look. Let's plot the first point. You guys ready to plot the first point? 2, 0. Where is 2, 0? Theta here is 0. Where's my radius of 2 now? Oh, it's positive 2, so I'm going to have to go 1. It should be right here. Is that true? That's a radius here now of 2. If we need to, let's make that bigger. Okay. Go down here. What's the next point I plot? I already plotted this point right here. I'm going to now plot 4 pi over 2. Pi over 2 is actually 90 degrees. Is that right? So 90 degrees, I now have a radius that went from 2 to what? 1, 2, 3, 4. You guys okay? What happened from 0 to 90 degrees? What happened in quadrant 1 here? My radius went from what? 2, and it increased to what? 4. And this is how we describe what happened in portion 1. Okay, you guys okay with that? What happens in portion 2? Let's plot again the next point. When the angle is pi, my radius goes back to what? 2. Is that true? Okay. Angle is pi. So, in other words, I'm going from 90 degrees to 180. I'm in this quadrant here, and my radius at pi, where does that radius go back to? 1, what? 2. And yes, this is not to scale, because really what's going on is there should be another circle here. So, for the lawyers in the world, you're absolutely right. It's not to scale. Yeah, see what I'm saying? You know, because this kind of doesn't look to scale. That first radius value should be here. And, you know, maybe one day I'll redo everything. And I'll put the right radius of 1, 2, 3, 4. Because it should be, you know, uniform. So I apologize to you guys. Not to scale, but okay. What's the point? That's the next point. And what does this radius go from 4 to what? To 2. And you should draw a nice smooth curve, so it doesn't look so beautiful. Isn't that a radius of 2 in terms of these lines there? So far, this is what we have, and this is going on in portion what? 2. What's happening now? What happens? Anybody see what happens here with this next point? What do I have to graph now? 0, 3 pi over 2. So I'm going to have to go to 270. And when I go to an angle of 270, which is right here, is that right? Where did my radius go to? It goes back to the pole. So I'm going to have to draw going from 2 back to the pole. Now, that kind of looks like this. I'll draw it nicer and smoother. There you go. And this is portion, what? 3. So let's now see what we do next. Go back to the graph. We're going to plot what? 2 pi. 2 pi is 360. So at 360 or 2 pi, where am I at now? Well, let's see. I'm at radius what? 2. Aren't I back where I started from? So at 270, I went from 0 to 2 in quadrant 4. I look like this. This is my quadrant 4. So this is portion 4 of the curve. We're going from here, 0 to 2. And again, I should point out to you guys, what are you looking at, or what should you be looking at? What is that called? This is a what? Cardioid. But it's an upside down cardioid. All right, you guys okay with that? It's an upside down cardioid. So I have only really 4 directions to go for cardioid. Right side up, upside down, left, and what? Right. So here's upside down. The prior one was, what was the prior one? Going to the left. And so we actually have 4 versions if you want to, 4 orientations. But that's how we graph cardioids. Okay, what do you guys think about that? Do you guys want to look at the original equation of that cardioid? Not necessarily. You should be able to do it. I mean, should we look at the original equation? Oh, you want to see more algebra? Okay, let's do it fast. R is 2. Was that plus or minus?
Plus.
Plus. Oh, I thought we were going to do minus. What happened?
You want plus.
We changed our mind? Oh, all right.
Well, you-
I might have? Okay. I don't even remember. I'm lucky I remember my name. I'm trying to remember why this, when I made this graph originally, or where I got it from, that first, it's always bugged me. I never mentioned it to you guys. Like, man, it's not to scale. That first thing, always bothered me. I never mentioned it, but it's not to scale. But that's all right. We can still use it. It just doesn't look as nice as it could be. And then, but my sketching, ability, if you look at that and say, you're never going to be a drawer in your life. And I know that, but both my parents were, ironically. And they had sons who were, who stayed away from the art, really. Anybody have parents who are artists? Anybody? I actually come from an art family. It's not just parents. It's like aunts, uncles, cousins, and everybody. Anybody have a family like that? They're just, multiply both sides by r. Do it really quick. See what we get? Because we want a graph. R squared is 2r plus 2r sine theta now. Okay? This portion over here will be x squared plus y squared. This portion here is just y. So you'll have x squared plus y squared equals 2r plus really 2y. And translate or move the 2y to the other side. You'll get x squared plus y squared minus 2y is actually 2r. And what you can also do again is do this process again. Square both sides here. The left, just leave it alone. The right, you get 4r squared. Now again, with this r squared, what do you replace that with? You replace this with x squared plus what? Y squared. So you're going to end up now with this representation. X squared plus y squared minus 2y squared will be 4x squared plus y squared. Now you could leave this alone and to say to you, this is the Cartesian coordinate representation. If somebody ever showed you this, if I ever got a tattoo, I might get this what? Equation on my arm, and then get this corresponding what? Graph right next to it. Nobody's going to really know that they're actually what? Related. Is that right? The Cartesian coordinate version here, in terms of your x and y axis, the x-axis again, and what is this? Your y-axis, Cartesian coordinates. The graph is what you're seeing here. It's this particular cardioid, and we could get rid of this detail. That's the graph. Anyway, it's always good and fun for me to start my day with cardioids. Okay, should we do another, or should we move on from our world of cardioids? Huh? You want another cardioid? Or should we move on?
You did negative.
Oh, you want a negative there? Okay. That's a good, okay. Let's do an example. How about if I say to you, R equals then, let's go out to now, what should we do? 3 or 4? Let's say this. Let's say 4. 4 minus 4, sine theta or cosine theta? Want to do sine theta or cosine theta? Doesn't matter. What do you guys want to do?
Cosine.
Cosine, okay. No big deal. Now remember, the key here is to just graph. R is negative 4 cosine theta plus 4. Okay? You're going to graph this. Now, how do we graph that? Be very careful. You have to first graph what? Negative 4 cosine theta, and then we shift how? Up 4 units. Isn't that what you guys are looking at here? Okay, you with me on this? We're graphing negative 4 cosine theta, and then we have to go up 4 units. So let's get to work on that, right? So negative 4 cosine theta. I mean, I might have to do some things here that are not exactly to scale, but that's okay.
The A value be negative.
Yep. There you go. Pi, 2 pi, pi over 2. Okay. Theta and what? R. You guys okay with that? No, you're gonna have your A value be positive. But A has to be positive. Yeah. Okay. What are we doing? Negative 4 cosine theta. So in order to do this, I have to do what? First cosine theta. Or I should say to you, not cosine theta. We have to graph 4 what? Positive cosine theta, right? And then we reflect the curve about the theta axis. Is that true? So 4 cosine theta. I'm kind of going to do it this way. Now cosine looks how? Cosine starts where? Up here? Is that true? And notice my amplitude. Positive 4, negative 4. So I start there. Then I go down to pi over 2. And then I go down here to negative 4. Back at 3 pi over 2 here. And then I'm up back at 2 pi. Isn't this my cosine curve? You guys okay with that? And that's positive amplitude, or I should say 4 cosine theta. I'm going to sketch the curve. So you guys are looking at this curve right here. 4 cosine theta, is that right? Now what do you have to do? How do you describe minus 4 cosine theta? Anybody remember? Yes. This is symmetric about what?
Theta.
About theta. So you're really going to have, let's actually change this. Here, 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 here. Reflect this about the theta axis. Now, personally, I'm going to get rid of all the other stuff I don't need here. Starts to confuse me and get in the way. So what I'm saying here is this is kind of a sketch, not a very nice one. Of negative 4 cosine theta. I need this. I don't need this. Because what am I going to do with this curve anyway? Once I have this curve here, I shift it how? Up 4 units. This is the up 4 units portion. Up 4. So let's shift that one up 4. Now notice what this then does for us. If I shift everything up 4, this point is now here. Is that true? This point goes up 4 here. This point, I'm going to have to erase everything. Goes up how many units? 4. 1, 2, 3, 4. So we're going to be here. I go up again, how many units? 4 units. So this point goes up 1, 2, 3, 4. And then this last point goes up 4 as well. So it'll be right here. Not pretty at all. Okay, let's kind of make this, oops, can't even erase nicely. Okay. Okay, it's barely legible. I hope your curves are better. Let's describe this with R and what? Theta. You guys okay? What's this first point going to be?
0, 0.
Good. What's the next point?
4.
4 pi over 2.
Yeah.
And then 8. 8 pi. And then 4.
3 pi over
3 pi over 2. And then
0. And then 2 pi.
0, 2 pi. All right, you guys okay with this here, this curve? We're going to plot every one of these points here. Okay, that looks like we're a good place. So let's plot these points. 0, 0, where would that be? At the pole, is that right? Okay, remember, you're going to go and look at these different regions of the curve. 1, 2, 3, 4. So my next point would be here at 4 pi over 2. So at 90 degrees, my radius now here is what? It goes from 0 to what? To 4. Is that right? So 4 would be here. 1, 2, 3, and 4. You guys okay with that? So here's my next what? That would be where 4 is. Let's put it in black here. Radius is 4. So you went from 0 to 4. So how should that look with this cardioid? Something like that. Is that right? And that's this first particular part of my curve. If I go back now and say what happens next, I went from 0, 0 to 4 pi over 2. I have to go to 8 pi. 8 pi. What does that mean? Radius is 8 when I go from 90 degrees out to what? 180. So let's see where this is. Oh, no, let's see. 1, 2, 3, 4, 5, 6, 7, and 8. Way out here. So I went from a radius of 4 to a radius of what? 8. Now let's try to do this. Okay, you okay with that? We plotted this point here. Now I got to go where? At 3 pi over 2, my radius now is what?
4.
4. So at 270 degrees,
So go down 4.
go back down to 4. Yeah, so let's see, where is that going to be? You might say that'll be, let's change the color. It's directly opposite, right? It'll be 1, 2, 3, and what? 4 now. So let's kind of draw this curve here if we can. We got to go now from a radius. This here is 4. Let's draw this. Try to be symmetric. Sorry. Let's see. Yeah, there we go. Does that look nice? No? Let's change that. Doesn't quite look like that, but nevertheless, okay, who cares? We may have to fix it anyway. Okay, what comes next? How does this curve go now? We're going to go to 0, 2 pi. 0, radius is 0 now at 2 pi, so where's that at?
Back to the pole.
Yeah, remember this is theta 0 and this is theta 2 pi, and you're right, we're going back to the what?
The origin.
Back to the pole. Anyway, this here again is region 1. We got what? Region 2, region 3, region 4. And yes, this radius here is going to be what? 0. So it's not a very good looking what? Cardioid. But nevertheless, it's a, this is kind of the approach to graphing for cardioids. I want to remind you guys that kind of thing. Okay, you guys okay with this one? Anybody have any questions on this that we just did? No? You guys sure? Should we look at the Cartesian coordinate version of this? Should we derive the equation algebraically? Okay, you guys like that, huh? What is this? 4 minus 4 cosine theta? R is 4 minus 4 cosine theta. So what you would do is you multiply both sides by r. You're going to do some algebra. R squared will be 4r minus 4r cosine theta. Notice, undo. R cosine theta and r squared, what are they? X squared plus y squared, and this is just x. So we'll have x squared plus y squared equals 4r minus 4x. Translate your term. X squared plus y squared plus 4x is 4r. And then I'll say to you guys, what do you do to both sides? You square that, and what happens now? You get x squared plus y squared squared. Oops, we forgot a big portion of this. I'll put it up here. X squared plus y squared plus 4x, everything what? Squared is 4r squared. And replace this r squared again with your x squared plus y squared. And so, final answer. Let's put it right here. You'll have x squared plus y squared plus 4x, everything squared, is 4 parentheses x squared plus y squared. So here's the Cartesian coordinate version of this cardioid graph. Let's plot that point, and we went back to the point, back to the pole. Cartesian coordinate and polar. Which is easier to describe? What was this? R is 4 minus 4. Yeah.
I think it's 16, right?
Oh, 16. Good job. So eager to end. Thank you. 16. So eager to get out of here. For what? Do we say cosine? Or was that sine? Okay. So you have the graph, you have the Cartesian coordinate representation, and you have the polar. Which one do you think was easier to use? Is polar easier to use? What do you think? Anyway. Looks like we're done. Only, I hope we... All right, here we go. Let's try this again. We know this is not a cardioid, is that right? Because of the form we have r equals a plus b sine theta. For cardioids, a has to be the same as b. In this case here, though, a is greater than b. So this is known, or I should say all of these are in the family of limicons, and this is going to be what's known as a dimpled limicon. Right? A dimple is like an indentation or a dent. So we're going to graph now r equals sine theta plus 3. So we need the graph of sine, and what we're going to do once we get that is this is going to be shifted up 3 units. So let's try this again here. So your regular sine curve is, I'm going to put these special points, 0, and I guess we have to go to what? 2 pi. Half of 2 pi will be pi. That half of pi is pi over 2. We get what? 3 pi over 2. Okay, go up 1, down 1, back at 0. I think I'm really doing that. All right, let's really do this here. Okay, the scale is really throwing me. So sine goes to up to pi, and then back down to what? Pi. 3 pi over 2, then back to 2 pi. There we go. Theta. This will be r. So we have points here, 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 and here. This is our sine curve. But this has to be, everything has to be shifted up how many units? 3. Let's try this again. So I'll say this 0 is going to be now where? At 3. Is that right? That's going up 3 units. Let me label that. That's 3. 1 has to go up to what number? 4. So that makes it here. Okay, your 0 goes up 3 units, which makes it here. Is that true? Because you have a new, in some sense, it's like a new theta axis in some ways, right? And then we're going to shift again up 3, so I should be here at 2. And this last point gets shifted up 3 units as well. Puts me back at that line 3. So you should have here this curve. This is going up to 4, back down to 3, to 2, and back up to 3. Now this here would be radius of 4. Okay, I think we're okay now. Let's look at these points here. So when my angle is 0, what's my radius? If we have to describe all this as r and theta, this is my radius axis again, right? So what's this first point going to be? 3, 0. And then we're going to be at 4 what? Pi over 2. And then we're back at 3 pi. And then we're going to be at 2, 3 pi over 2. And then we're going to be back at, what's this? 3, and that's 2 pi. So it looks like we're pretty good now. Now we're on our way here to graphing, the polar version. So far, so good. Anybody notice anything here? We're okay with that? So let's see. Hopefully, if I'm lucky, let's try this out. There we go. So let's plot some points. You guys ready? What's the first point we plot? You're going to tell me we're going to go out to what? 3, 0. Is that right? So let's kind of enlarge this and see where 3, 0 would be. We're going to the right. And I'm going to try to, should we try to do this to scale? This would really be 1, 2, 3. Okay? Let's just fix this now since we're here. That's the location of 3, 0. Okay, because your angle here is 0, and here's my radius of what? 3. Is that true? There's my first point. Now, what's the next point? 4 what? 4 pi over 2. So when we go 90 degrees here, we rotate 90 degrees, we're no longer at 3, we're now at what? At 4. So this is 1, 2, 3, and 4. So here's the location of that next point. This is 4 pi over 2. So how did my radius behave? I went from 3 to what? To 4. So here's 4 again. Let's label this here as 3. So my radius went from 3 to 4. So I'm getting larger in that first quadrant. So we just described here what happened in this region we called 1 here. So this is portion 1. Now we're going to do portion 2 here. So radius went from 3 to 4. Now going from 90 degrees to 180 to pi here, notice what happens. I'm back where? I'm back at 3. So at pi, 90 degrees, I'm back at 3. So I'm going to go 1, 2, 3 again to kind of keep this in proper perspective to scale. There's the location. And this location is now going to be a radius value of what? 3. So there I am. And if I color this correctly, this was part of 1 and this is part 2. We need 3 and what? 4. So we're up to this point right here. Okay, anybody have any questions on this one? What's the next angle we consider? 270? 3 pi over 2? So at 270, what's my radius? What's the radius? Right here, is that right? My radius 2? Okay. So 270 degrees looks something like this. So we're going to go, I guess, it's over here. 1, oops, wrong thing. The radius was 2, right? 1, 2. So the point will be right there. This is where I have a radius value of 2. And so portion 3 now of the curve, as I go in quadrant 3, looks like this. And then finally, the end here, going back to, looks like where we started, to 3 to pi, going back to that point in quadrant 4, I go all the way back to 2 pi, and I'm back at the radius value of what? Of 3 again. And so this will look like this. And here's going to be what happens in 4, I guess. Okay, so you're taking a look at what this is. Now, this isn't a beautiful, smooth curve. You guys already know the story. My parents are artists, but, their sons are not. This is really what you would do if you wanted to graph this particular limicon. And notice it is not a cardioid. And we said that was 3, yeah. Okay, something like that, not so beautiful. You guys can make this nice and beautiful. Very hard to do for me on the iPad, to sketch it. I do a lot better on the board for some reason, for all those years of experience, but an iPad, very difficult for me. Okay, but this is kind of how you guys go about this. Now, let's talk about something else you can see. And notice, I guess, well, what is this one? Is there any dimple here? I guess there's a dimple. If I go from radius 3 back down to 2, the dimple is supposed to be somewhere here, but anyway. Okay, let's look at some more curves here. I want to give you guys another sort of category here. We got something called roses here. Now, roses, you have equations here. R equals maybe A sine n theta. And you got R equals A cosine n theta. Now I'm going to say in some cases n is even and n is what? Odd. So you have n is even, n is odd. Now when n is even, we have what's called 2n roses. When n is odd, we have n roses. Maybe to be more specific, leaves. So if you have an odd value, well, that'll give you an odd number of leaves. If you have an even value, essentially you double your leaves. So we're going to look at some examples here of roses. So my first example I'll give you maybe is going to be this. We'll say here. R equals about 2 cosine double theta. Now, what do you guys know about n here? Here's what you want to know. What do you guys know about n? It's even. Since n is even, how many leaves can we expect? 2 leaves? Say no. If you have an even number, n is even, how many leaves can we have? 2 times n leaves. What's n in this case? 2. So since n here is 2, we're going to have what? 4 leaves right over here. So we know what to expect, 4 leaves here. Now, here's the approach, like we said before. The approach is going to be the same. We're going to graph r is 2 cosine of what? 2 theta. So r is 2 cosine 2 theta. What that's going to mean for us, ladies and gentlemen, is we're going to see this kind of effect. Consider the period, because if we're going to graph this 2 cosine 2 theta, what's our period going to be? Isn't it 2 pi over 2? Or is pi? Bless you. R theta. This will be pi. What is this? Pi over 2. And what is this? Pi over 4. And what would this be? 3 pi over 4. So yet again, we're going to graph r equals 2 cosine 2 theta here. We have to know the graph of cosine, and cosine goes how? Down to negative 2. That's our amplitude. Back up to positive 2. And then, I'm sorry, back up to 0 and then positive 2. So let's do this a little better. And let's actually label this here. Okay, we'll label it here. Well, we'll do the purple again. So this point, this point, this point, this point, and this point. These are all points we have to consider. R versus what? Theta. So if my radius is 2, angle is 0 here. Radius is pi over 4. 0 radius. Oops. Radius here will be what? What's our radius? -2, and our angle is pi over 2. Radius here is going to be 0, angle is 3 pi over 4. Radius here is going to be 2, angle is 2 pi. R theta. Pi, thank you. Okay, that's the graph of r equals 2 cosine 2 theta. So as you guys can see, if you said, hey, you know, Mr. Judge, is this final going to be comprehensive? What do you think I'm going to say? Sure, because you have to know how to graph in order to do something like this. Now let's go to the polar. Let's plot all these points and go to our polar graph. Okay, let's go and plot these. What's our first radius for angle theta being 0? Isn't that 2? So I'm at 2 units. Let's go here. So far, so good? 0 angle, radius is 2. Now, what did I just do here? I plotted this point right here. I'm going to have to plot this point here. Radius is 0, but the angle is pi over 4. What's pi over 4? Is that 45 degrees? Isn't that pi over 4? So somehow my radius went from 2 to what? 2 to 0? What is 0 pi over 4? Isn't that the pole? So let's see. The radius went from 0, or I'm saying 2 to 0. So I'm going to have to do a shrinking radius here. Never cross that line, pi over 4. It looks like I am, but there we go. Could do a little better. There we go. Let's just stick with that. Okay? Now, what else is happening here after I go to 0 pi over 4? What's my next plot? I got to go down to what now? At 90 degrees, my radius is -2. So at 90 degrees, so I'm going to go again here, rotate in this portion here. Okay. And now I have to have a radius here of what? -2. Could you guys tell me where am I going to be here? If I take this, let's get rid of, well, let's do something like this. How about this? I'm going to rotate now from 45 degrees to 90 degrees. And let's use this blue. I'm going to show you what's going on. Here's my, well, when I blow it up, it's kind of not. Here's my angle in the particular. Let's do this. Here's my angle. Do you guys appreciate that? If I said I'm taking my polar axis and it's now rotating here from pi over 4 to pi over 2. Every radius value there is what? Is positive. Is that true? Where would the negative radius values be? Because I'm going to have to go to 90 degrees, pi over 2, and my radius is -2. So what's happening here, you got to pay real close attention, is that all those radius values are going to end up being -2 is over here. This is going to be, we said 1 and what, 2? So all those radius values are going to be over here. And that's really where this, I should say, -2 radius is, because they're opposite this particular region from pi over 4 to pi over 2. The radius values are negative. They're opposite there. And that's a key. That's a very big deal. So I want to really have you guys focus on that, is that because the radius is negative, it's opposite that blue line if I'm taking this polar axis. Isn't that consistent with your plotting of your points? And then I'll say this is just going down. If you really wanted to pay details, this is 1, this is 2. We just looked at 1 here, and this is now what? 2. We're going to have to go from a -2 radius now back to 0 for 3 pi over 4. This is the point that we're looking at. 0, 3 pi over 4 now. This is where 3 would be. So 3 pi over 4 is somewhere over here, to remind you guys. This is now 3 pi over 4. So my radius, if I'm going to focus now in this quadrant here, or this region, I can't call it a quadrant, it's a region. Let's focus now here in this region here in detail. Let's get rid of this. You guys know that this actually here is up here at pi over 2. We can put it there. My focus now is right up in here. Pi over 2, I guess that's a different blue. Yeah. We're looking at pi over 2 to what? To 3 pi over 4. We're looking down here, right? So going to 3 pi over 4 here, going from this point to this point, my radius goes from -2 down to 0. So how does that look? Well, it's a negative radius. What does that mean? Negative radius means all my values are over here on this other side. And I'm going to have to go somehow from -2 back to 0. Is that right? 0 is the pole. So I have to go from -2 to 0 without really crossing that line. And let's try this out. -2 to 0 somehow. Yeah. Okay. So I'm back at the pole, and that's actually what's happening for a region or portion of the curve called 3. And it's getting a little messy there, so I'll erase that. This is where 3 would be. So appreciate now where we're at. We're going now back to where? Back to 2 when my angle is pi. So I'm going now not to 3 pi over 4. Let's erase this. We're really talking about something here. 3 pi over 4 to pi. This is where pi is. So in this region, 3 pi over 4 to pi, notice here, our curve is what? Positive. So we're on that blue axis. And we're going to go end up to radius of 2 for angle theta being pi. So we're going to have to go now to, let's kind of find where this would be. 1, 2. And now my radius goes back to, it's positive. So I'm in the blue, but I'm going to have to go back to this value 2 here. So here's my radius here. Let's try to make it a curve that isn't very what? There we go. So there's some things going on here, and let's blow this up to show you this is where portion 4 would be. Anyway, this is kind of like a, maybe it looks a little better that way, okay? So let's get rid of all those 1, 2, 3s here. Let's get rid of all this information, except for what we really need. And I want to say something about this that's important. This is only from 0 to what? Pi. So why is this only from 0 to pi? Anybody want to tell me? Why do you think this is only from 0 to pi? Well, that's one cycle, but more importantly, what's the period? Period is pi. So what do you think I'd really have to do to continue this? What do I have to do? Go all the way out to what? Go out to 2 pi. So, I mean, I can sketch my curve out to 2 pi. Okay, you guys with me on this? So in some sense, I can say to you, well, and you know, if we had a lot of time, I'd go, okay, I'd show you guys, guess what's going to happen. Go now out to, this is going to be, if this is 4 pi over 4, this would be what? 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. You guys know this is 2 pi. This is 3 pi over 2. Okay, so I would say to you, you know, you're going to have to sketch another cycle to get to the 2 pi. Down here, maybe down what? If I can see it. Actually, yeah, that's my, go out here, here. I think I missed something. Yeah, so I'm going out to here, 5 pi over 4. Actually, I had it right. Undo. Here we go, 5 pi over 4. And then down 2 here to 3 pi over 2, 7 pi over 4, then back up to 2. So what else? What I could say is, you know what? There's some additional points here. You go down to this point with radius, this alpha, or I'm sorry, these angles with various radiuses, and I can erase some of these. I can continue. You guys with me on that? But I want to remark about something here about cosine. Okay? Let me give you guys a remark. About even and oddness. If you're even or you're odd, what do you know about cosine? If I told you r is 2 cosine 2 theta, if I replace my theta here, see this theta? I want to replace this theta with negative theta. What happens when I do that? I got r is 2 cosine negative 2 theta, or r is 2 what? Cosine 2 theta. And so what you're seeing here is two things. That r is actually, or we should say, since cosine is that even or is that odd? Doesn't that mean cosine's what? That's an even function. What does that mean about our symmetry? So we're going to use some symmetry here. What does that mean about symmetry? If I show you a polar curve here, here's our pole. Here's the polar axis. Okay? Notice what just happened. R theta would be maybe somewhere here. Okay? Is that r theta? Some point r theta. What do you guys know about r minus theta? Draw a line here. What does this say about this r minus theta business? Where's minus theta at? And this from minus, if this is theta, this would be possibly what? Minus theta. Is that right? This is r, and this is minus theta. What kind of symmetry do you think you're considering here? Is this symmetric? It's symmetric about the what? Well, are the polar what? The polar axis. Why is that a big deal for us here? If we know this curve is symmetric about the polar axis, if I put a mirror over here on the polar axis and I reflect the image on top and bottom, that's what we really say. You can reflect the top and it'll be on the bottom and vice versa. Is that right? That's what being symmetric about this polar axis means. What does it mean for our curve here? You guys know what this means? Let's put this reflection. I'll put the reflection here in blue. To be symmetric about the polar axis means anything above this pole here. Here we go. Anything above is reflected where? Below. And anything below is reflected how? Above. Is that true? Now, why is this a great benefit? If I put my mirror, because of being symmetric about the polar axis. Let me show you. I can now simply say this portion is on the curve, and so is this bottom what? Go up to 2. This bottom portion. Are there 4 leaves in this rose? There are 4. We knew that they would be. What about this over here? Can I approach it by actually plotting all these additional points and looking at the radius values again? The answer is yes, but which would you rather do? If you know about a curve being symmetric about the what? Polar axis, I would say this saves you some time. Is that true? Because this is now a radius of 2 again, way up here. And I would say to you that, yeah, this saves me a lot of time. So here's kind of what you'd look at doing if you had to graph a rose. So in the polar world, we have both roses and what? Cardioids. So maybe if you think about that Valentine's Day, roses and cardioids in the polar world. This is how you graph a rose, a 4-leaf rose. Now, I can show you how to graph 3-leaf roses and so on, but what I want to do now at this point is to graph a lemniscate. Okay, so anybody have any questions on these roses we just did here, or this 4-leaf rose example? You can have 6-leaf roses, you can have 8 leaves and blah, blah, blah. You can have 3 leaves. Typically in a trig course, they give you 3 leaves and 4 leaves. So at this point, I would do a 3-leaf, but I want to do a lemniscate. And let me actually show you this lemniscate idea. Try to get some of these in here. Here's some lemniscates. You guys know what the informal phrase for lemniscate will be? It's a figure 8. So there's some details here to talk about. Let me give you your first example of a lemniscate. R squared will be 4 cosine 2 theta. Now, this is not a rose. Does anybody know why this isn't a rose? You have R what? Squared here. Okay? So lemniscates are of the form, and I'll give it to you in general. R squared is A squared sine 2 theta, and R squared is A squared cosine 2 theta. Here's a lemniscate. Think of them as figure 8s. So we're going to first graph this lemniscate as an example. Okay, there's a very important detail here. Now, the approach is exactly the same. Here's theta, and instead of r, we're going to call this what? R squared. Okay, you okay with that? So on my left side here, this is my vertical axis. It's going to be r squared. And I'm going to plot that versus a theta value. And notice again my period. What's the period here? Pi. So let's go out to pi. This is half pi. This is a quarter pi. 1, 2. This is 3/4 pi again. Okay. Because of the fact that I also have n here being 2, and so you guys remember the period will be 2 pi over 2, which is just going to be pi. That's my period. Now for r squared, I have an amplitude of 4, so I'm just going to do it this way. This is 1, 2, 3, 4. 1, 2, 3, negative 4. This is my cosine curve. So our first point will be up here. 4, pi over 4, pi over 2, 3 pi over 4, back up to pi. Let me draw the cosine curve. So if we go through this again, here it will be 1, this will be 2, this will be 3, and this will be 4, like we've been doing. So I want you guys to be very careful of what's going on here. Let me emphasize this here. This is not r, but it is what? R squared. That's going to be a super big deal. Let me show you why. Let's bring in our polar graph here. Let's start to graph this. Okay. You're going to have to remember a little bit of algebra here. It's not much. If I told you guys a couple of things here. What's our first point? You know how we've been labeling these first points? Remember we've been saying our first point is right up here? We call this maybe radius is for angle 0. Is that true? We got to determine points r theta. So we've been talking about that point, this point, this point, and this point. Is that true? Here's the problem though. If you said the radius is 4, you're actually wrong. Why are you wrong? This is r squared. Good job. This is r squared will be 4. But what does that mean about r then? Plus or minus square root of 4. R is plus or minus 2. For what angle of theta? Something for theta being 0. So for theta being 0 right here, I actually have 2 radius values. Is that true? Only because this is actually r squared. So for 2 radius values, they're both positive 2 and negative 2. Let's see where they would be. Where would they be? Here. 1, 2. There's my first radius. Where's the other radius? On the opposite side, because that radius is actually what? Negative. So you can say this is 2, 0, and this would be negative 2, 0. You guys okay with that? That's when theta is 0. So I have actually 2 starting points. That's key to my figure 8, my Lemniscate. 2 starting points. Okay, now let's remember here. What's our next point then? We got to go from both directions to this point over here. What's this point going to be? Anyone want to tell me what this point is right here? It's actually the pole, you're right, because what's my radius here now? At pi over 4, you can say r squared is 0, or r will be plus or minus square root of 0. You'll say, oh, r is 0 here. You're right, for theta being what? What's the angle for theta? Pi over 4. So let's see how this works. Okay, pi over 4 we know is 45 degrees. So okay. Keep in mind, what are we doing here? We're going from a radius of 2 to the pole, radius of 0. This here is pi over 4. We never actually cross that. So how that looks is I'll start here at radius of 2, and I'm going to go to the pole. Similarly, I'm at negative 2, and I have to go where? To the pole as well. But these are all negative radius values, so I'm going this way. So what I want to say to you is, from the beginning here, we're starting at 2 points. Okay. Undo. Good. So negative 2, and this version of 1 here that we're looking at right here, I have 2 radius values. One positive, one what? Negative. So for any angle here in blue in this region, from 0 to pi over 4, I got a positive radius, and the opposite is a what? Negative radius over here. So I'm plotting 2 radius values, all from 0 to what? Pi over 4. So that's the picture of it. And that's what's going on. Now something else important is happening. See if you guys can figure this out. What else is happening? What do you guys think? What's happening over here? Let's actually put this, yeah, I don't know, I want to change that color. Let's change it to yellow. We haven't used yellow. It probably is a bad idea, but yeah. Huh? Yes. What's going on here? Well, whatever color, what's an undefined color? Red or green? I don't know. What do you guys, what's an undefined color? Brown? I don't know. It's all, you know, the same color practically on the screen. R squared, remember R squared? R squared could never be what? Negative. So for these values here, okay, for these angles, what I'm saying is, right in here for these angles, all of these angles, well, R squared would be negative. So we're not going to graph these points here, really, anything in this portion right here. So you can actually get rid of, you know, this portion of the curve if you wanted. And, you know, you're really focusing on these 2 portions here. Because R squared is negative for that bottom portion there. Because we graphed actually R squared here. And that's the problem. Or it's not really a problem, it's actually a pretty nice situation. Okay, you guys okay with that? Now I'm going to say to you, what you really go to, in all honesty, is right here. You go to 4. At 3 pi over 4 and pi, now you have to locate 3 pi over 4 and pi here in this region. 3 pi over 4 and pi, this is where 3 pi over 4 would be. Is that right? And then this is where pi would be. So I'm going to focus now, I'm going to get rid of this here. Get rid of this purple. I'm now going to focus on that particular region. 3 pi over 4 to pi. And everything in blue has a positive radius, and then everything in red has a what? Negative radius. You guys okay with that? All along this region now. So let's see what's happening in this region. We're going at 3 pi over 4. Our radius is actually 0. Okay? So where is that radius value? 3 pi over 4, our radius is where? 0. So we're at the pole, just so you guys know. And then going from the pole, this here, 3 pi over 4, radius 0, we got to go up to a radius of 4. Is that right? But it's not really a radius of 4. What is it? R squared is 4. Again, R is plus or minus 2, and that happens when theta is pi. We're talking about this point here. This is where R squared is 4. Take a look. Am I right about that? See this 4 value for R squared? Happens when my angle is pi. So I have 2 values going in that region again. I'm going from the pole right back to what number? What's the radius? Plus or minus 2. So let's kind of see what this looks like. The pole, and I'm in region, I'm over here. I'm going to have to go from the pole to a positive radius value of 2. So I'm going like this way. You agree with that? I'm also going how? Negative radius. So right in here, from this 3 pi over 4 to pi, I have 2 directions. One positive, one negative. One going to positive 2, the other going to what? Negative 2 right here. I know it's pretty, there's a lot going on there. However, what you guys see here is what's known as a what? A lemniscate. Not so beautiful in my pictures, but you know, this is how you start to graph these polar curves. Now, this is a lemniscate. We have other lemniscates to consider. If you had r squared is going to be maybe 4 sine 2 theta, this lemniscate is going to be rotated about, you know, from this angle theta being 0, it's going to be rotated about pi over 4, I believe. But, you know, I'll get some more videos up on that and do some more of these polar curves for you guys. Okay, but this is one I definitely wanted to get in because it's a classic curve you see. And this is the equation here that you get for this lemniscate. R squared is going to be what? 4 cosine 2 theta. Anything of this form we call lemniscates. Figure 8. Here's the picture.